Hey friends, Vincent here. Welcome to Fearless in Rust, where we keep Rust clean and simple. Let's get into it. Today, we are finishing the Hexagonal Architecture series. Part 1, we designed the domain, pure business language. Part 2, we built the application layer, use cases plus ports. And now, part 3, the edges, handlers and adapters, where the outside world actually touches our system. Here's the premise of hexagonal architecture in one sentence. The core defines what it needs and what it can do, and the outside world adapts to it. What does that mean? The HTTP layer should only know the input port traits, what the app can do. Persistence should be an output adapter that implements an output port trait, what the app needs. And the only place where we connect real HTTP plus real storage to the core is the writing module in the startup file. Alright, let's work the RustPulse code and make that concrete. First, let's start with the input adapter, an HTTP handler calling an input port. Right at the top, the handler imports telemetry query case. That single line already tells you we are doing hexagonal correctly. The handler depends on the port, not on service struct, and not on any repository. Now, look at the routes function. This function is the HTTP adapter's entry point. It builds the Axum router for telemetry endpoints. And the important part is the parameter. It doesn't take telemetry service. It takes ARC-DIN telemetry query case, that's the contract. DIN means any type implementing the port trait, and ARC means shared safely across concurrent requests. So the HTTP layer only knows one thing. I can call fetchAll on something that implements this trait. It doesn't know what the implementation is. Today is telemetry service, tomorrow it could be a mock for tests or a different implementation, and the handler code doesn't change. That's the boundary. The adapter depends on the port trait, not the concrete service. Now, inside the router construction, we rewire three things. First, the endpoint. Second, the dependency injection. This tells Axum attach this service as shared router state, so every request to these routes can extract it via state. And the boundary middleware. This is where we keep request tracing and HTTP concerns at the edge, not in the core. Now let's jump to the endpoint himself. This function is pure adapter responsibility. It reads web inputs, query parameters, it translates them into a core-friendly input, then it calls the use case through the input port. Right here, this is the key line, the use case call. That's the hexagonal moment. The handler is basically saying core fetch telemetry, optionally filtered by this ID. And notice what the handler never does. It never opens a file, it never runs a query, it never mentions JSON telemetry repo, it just bridges HTTP with port call with HTTP response. That's exactly what you want. Your HTTP layer stays thin, replaceable, and boring. Middleware stays at the edge. Now let's switch to the other side, persistence. Here we have one output adapter. Its job is the opposite of HTTP. It takes the coarse abstract repository requirement and turns it into a real I/O. The core defines the output port trait telemetry repository. This file implements it right here. And right here also you're allowed to see messy infrastructure details because we are at the edge. File I/O with open options, buff reader and write, as you can see here at the top. And at that point, reading and filtering telemetry with query all, and parsing the filter values as UUID with UUID parse str. So yes, Adapters can be dirty with I/O, that's fine. The important thing is the dirt stays outside the core, behind the port trait. Now the composition route, where everything is wired. Here we actually connect HTTP handler plus telemetry service and JSON telemetry repo. That's the wiring module. This is the one place where we are allowed to break abstraction and assemble the app. Here we choose the storage file with metrics data.jsonhel. We then seal it with sample telemetry for demo with mock data generator. Then we build the output adapter with JSON telemetry repo new. And we build the core use case implementation with telemetry service new. And finally, we inject it to the HTTP adapter routes with telemetry handler routes. That's the full hexagonal flow. Core defines ports, adapters call implements ports, and infra wires real implementations. Now the demo part. So first, let's start again the backend. What this does is boot the server and also wire the whole hexagonal setup in the composition route. In start server, we first decide where telemetry data will live. Then we generate mock telemetry and write it to that file, so the demo has data. Then we build the output adapter, the concrete repository that knows how to read-write JSON-Hel. Then we build the core use case implementation by injecting that repository into the service. And finally, we inject the use case into the HTTP routes. So before we even send a request, the important thing already happened. Infra created the adapter, injected it into the core service, and injected the core service into the HTTP adapters. Now, step 2, let's make the HTTP call. That request enters the system through the HTTP adapter with routes and get metrics. Now, step 3. Handlers has to translate HTTP into a clean use case call. Inside this handler, we do 3 adapter tasks. Read HTTP inputs, translate them into core input, and call the core through the input port. This is the key. The handler doesn't fetch telemetry from a file. It just says use case fetch telemetry. Now step 4. Use case delegates to the output port. Now we switch to the output adapter in JSON-Hel repo. This JSON-Hel repo opens a file, reads it line by line, deserializes each line into a domain telemetry, and returns vec telemetry back to the core. So here we have clean domain objects, not rows, not HTTP. So now step 5, handlers translate the output back to HTTP. Back in the handler, on success, it turns the domain objects into JSON and returns OK status code. So we entered through an input adapter, crossed the core through ports, hit an output adapter, and came back out as an HTTP response. Okay, now let's wrap up. So, the final part of hexagonal architecture is really about discipline at the edges. Handlers don't do business logic, they translate and delegate. Repositories don't link into the core, they implement ports. Infrastructure wires everything in one place, and nowhere else. That's how you stay fearless. The core stays clean, the edges stay replaceable, and the system stays easy to evolve. So, thank you for your time. See you there.